Hey, stat students, we are going to talk about residuals and how to interpret them. So here's the deal. When we go to this problem down here, number 17, we've got to interpret the residual. So first we've got to get the residual to be able to interpret. So number 16 here says find the residual for the point that has number of pets at 5 and time spent outside of 90. So that's the actual point. You'll see that point circled there in orange. So what's the way to calculate a residual? Well, let's start there. Residual is your actual y minus the predicted y. So think about it in terms of this. It's like your real actual point, the y value for the actual point, put actual here, minus what would be the y value in your predicted line, and that's shown by this y hat here. It's a hat. Okay, so whatever value you would get for the y, and we call that the predicted. Okay, so when I highlight my question here for number 16, I'm going to need the x, and I'm also going to need the y. Okay, so here's my x, 5, and here's my y, 90. So we already have the y. That's our 90. What I need now is the y hat, the predicted, and that's where the x comes in. So we calculate the y hat. In this case, we see that as time. So we calculate y hat by saying 51 plus 4.7 times 90. Okay, we plug that into our calculators. And actually, I made a mistake here, right? 90 is my y. Our x is 5. So I should be plugging 5 in for x. All right. Sorry about that. So we come back and we plug that in. We get an answer of 74.5. That's my y hat. So now I can take that number and subtract it, and I've got 74.5 here. And we've got our answer, which is 15.5. Okay, so that's important. Our residual is a positive 15.5, which makes sense, right? The point here is above the predicted line. So when we go to actually interpret this value, here's the framework that we're going to use. All right, we're going to talk about the actual y content or context and tell if it's higher or lower than the predicted. So if I look at the graph, we see that the y here is higher than the predicted. It's the points above the graph. And that makes sense because our residual is also positive. So I'm going to take this framework that I've given you, right, the residual interpretation. I'm going to copy it. So Control C after I highlight it there and post that in for my answer for number 17. But we want to put it in terms of this problem. So where it says y context, we're going to talk about that as time spent outside. How do I know that's the y context? Well, there's a couple places we can look, right? First place would be the graph. See at the y, it says time spent outside. Second place I could see that is in the equation. It says time. All right, so we've got that part. The next part is what was our residual? It was a positive 15.5. So take that and we plug that in. It's positive 15.5. So the actual time spent outside is 15.5. Is it higher or lower? Well, we can even see that in the point, but also the residual is positive. So we say higher. So I remove that. Higher than the predicted, higher than the line, right? And where did that happen? For what value of x did that happen? Well, what's our x context? Our x here is number of pets. So we change that. We can see that in the graph. We can see that in the equation of the line. And where did that happen? For what value? It was 5, not 90. Our x is 5. For the number of pets, that was equal to 5. Okay? And that's your framework. Use that every time you have to interpret a residual.